Hello friends, I am back. I am back with webinar number 29. Being learner and technology lover, whenever I come across new technology, it becomes difficult for me to say no. It becomes difficult to say no because I love to educate people about the new technology available, and we are on a mission. We are on a mission to make our India, our nation, our country free of electrical and fire accidents. And we have to use the technology available. And I discussed the new technology with Mubarak Khan, and we decided to go for this webinar on very important topic of key aspects of hospitals, operation theater, and ICU power supply as per NEC SP30 2020-23. It is well known fact that news of every fire or electrocutions goes deep into our mind and heart. Everyone have a feeling of extreme pains, and in fact forces everyone to ponder over the causes, culprits, victims, role of authorities, role of individuals, regulations, rules, enforcement, negligence on parts of agencies, negligence on part of individual, etc. Just imagine or consider a worst of the worst case where the fire taking place in operation theater or ICU, where the treatment of patients are going on. Patients are on the bed under intensive care and the fire take place. Here there are two major responsibility comes. First is to douse the fire, and second is related to the evacuation of patient on the bed. This is the area which needs special attention. In fact, very, very special attention. We have some documents available with us in the forms of code and regulations. That is NEC SP30 2020-23, and Part 3, Section 9 covers the same thing. We have another IS 17512, requirement of electrical installation in medical location. CA Safety Regulation, Regulation 56, talk about X-ray and high frequency installations under chapter number 6, about safety provision for electrical installations and apparatus of voltage exceeding 650 volt. When I talk about importance of that thing in respect of the medical equipments, we have to understand certain things that are the applied part, the part of electrical equipments that is going to be in contact with the patient. We have to understand group 0, group 1, group 2. Locations in that hospital medical location site. We must have knowledge about SCLV, safety, extra low voltage, protective extra low voltage, functional extra low voltage. We have to understand that these medical locations are basically provided with IT earthing system. And in IT earthing system, it becomes mandatory to have insulation monitoring systems or device. And that device are according to IC 61557-8. Sometimes we have to provide isolation transformer as per IC 61558-2-15. We have to use supplementary equipotential bonding. We should not forget about the initial and the periodic inspection verification. An important part is the changeover period and the EMI. electromagnetic interference. We have to understand the classification based on the safety services for medical locations like class 0, class 0.15, class 0.5, class 15, and class more than 15 seconds. I always start my webinars with Thanksgiving, and I don't want to fail in my duty if I don't mention the name of my mentors. And from the core of my heart, I would like to thank my family, my well-wishers, my mentors, my supporters, and friends. In that list, first of all, I would like to thank Almighty for giving me blessings, my family for their unflinching sports, my mentors respected Vaisa, Anjali Chandra, ma'am, K.K. Murthy, sir, N.K. Mittal, sir, P. Ramachandran, sir, S.F. Pao, sir, Hitesh Chauhan, sir, Kamal Bansal ji. The list of my friends, Saket Gupta comes first, then Dinesh ji, Dr. Vikas Almari, S.K. Batra ji. Last but not the least, my team working day and night for making this webinars to happen includes Gulab and Ramdhani. And to discuss this important topic, I am with respected Mubarak Khan ji, who is the founder and CEO of Muhandis Industries. He is basically passionate engineers, technology lovers like us, and he has also joined the hands of IPE to make India free of electrical accidents. He is from the merchant navy background and he has served many reputed companies in top management positions before starting his own company. He has 15 years of rich experience and has served domestic as well as international markets for technological advanced products and solutions in the field of condition monitoring, safety, and automation. Now, time has come to hand over this stage to Mubarak Khan ji to share his invaluable experience on the subjects we are going to discuss. Welcome, sir. Stage is now yours. Kindly unmute, sir.
Thank you, Rajesh ji. Am I audible now?
Yes, yes, you are.
Yes, yes. Thank you, Rajesh ji, for the nice introduction and setting up the stage for the discussion which is going to come. I think within these 2-3 minutes, we have covered so many points that now I become a little bit nervous whether I'll be able to justify that thing or not. Okay. So without wasting any much time, I'll start with the presentation and we will carry on the discussion through that. Just confirm if my screen is visible.
Yes, sir, visible. Please continue.
Okay. So we will go through the presentation and you can note down your questions and we can have the discussion during the question answer session at the end of the presentation. Okay, because the topic is really very vast and there are so many small points which needs to be covered. It is definitely obvious that I'll not be able to cover all in detail, but so I'm going to touch upon various points and going to focus on 1 or 2 points in detail so that we can have a good understanding of at least few aspects. Okay, so once again, thank you on behalf of Active Electrotechnic and Muhandis Industries. Thank you for joining us for this webinar on key design aspects of hospital OT and ICU power supply as per NEC SP30 2023. Why and how? My name is Mubarak Khan. I'm founder of Muhandis Industries and much better introduction is being given by Rajesh. Okay. So just a brief intro. So Muhandis Industries, production solutions, we are offering electrical safety and condition monitoring solutions, headquartered at Madgaon, Mumbai, India. And we have a small factory at Nalasopara, Thane, Maharashtra. And founder is myself, and we are authorized partners of Active Electrotechnic, Turkey. Okay, so Active Electrotechnic is basically, it was established in 1981 and currently they are serving more than 85 countries worldwide. And the main products are MVLV switchgear, substation reactors, capacitors, power quality and harmonic filter systems, energy management systems, load banks, etc. They have a manufacturing facility in Sakarya, Ankara, Istanbul in Turkey, and Jiben in Germany. Okay. So these are the, I'm just giving a very brief because that we should not waste time on this discussion. And medical isolation panel is also a part of active electrotechnic product basket. Okay. So coming to the topic, key design aspect of hospital, OT and ICU as per NEC. Okay, so let us first start with the purpose. Like, why are we discussing this topic in first place, right? What is the purpose of having this kind of standard, or what is the purpose of creating awareness or talking about it in first place? Okay. So these lines which I have mentioned in the slide are directly taken from the NEC standard, and it's directly referred. It says that in medical locations, it is necessary to ensure the safety of patients likely to be subjected to application of medical electrical equipment. Okay? For every activity and functions in the medical location, the particular requirement for safety have to be considered. Safety can be achieved by ensuring the safety of installation and safe operation and maintenance of medical electrical equipment connected to it. So there are two types of operation and maintenance which are there. One is the periodical maintenance which is there, and second is the AMC part, which is mentioned already in the standard. But because of lack of time, I have not covered that one, but that is also there. Okay. There is one more standard is there IS 732, and there are other standards which mention maintenance of medical electrical equipment. That also needs to be considered at the time of deciding the maintenance plan. But here I am covering only NEC SP30. Okay. The use of medical electrical equipment on patients undergoing intensive care of critical importance has called for enhanced reliability and safety of electrical installations in hospitals, so as to improve the safety and continuity of supplies, which is met by application of this standard. Okay. Variations of standard for further enhanced safety and reliability are acceptable. So to ensure, basically, if I summarize that, it is to ensure the safety of patients and medical staff. Okay. So where is it applicable? These all these words and terminologies are mentioned in the standard itself. It is applicable for new hospitals, existing hospitals. If application of the location changes, veterinary hospitals, private clinics, healthcare centers, medical dental practices, dedicated medical rooms in the workplace also. Okay. Just to summarize, wherever the healthcare professionals use medical electrical equipment on patient body directly, these standards must be applied. One more point to mention is, like as it is mentioned, if applicable, application of the location changes. What it means that in medical terminology, there are the medical locations are divided into 3 zones: Group 0, Group 1, Group 2. And for each zone, the safety provisions required are different. So if the application changes from Group 1 to Group 2, definitely the safety provisions need to be checked whether it is complying to Group 2 or not. Okay. So coming to the classification of various locations in hospitals, so we have 3 main categories: Group 0, Group 1, and Group 2. Okay. Group 0, by definition, it means that places where no medical electrical equipment is expected to come in contact with a patient. Okay. Where no medical electrical equipment is expected to come in contact with a patient. For example, massage room, office, OPD, waiting room, etc. Okay. Second is the Group 1 location, places where medical electrical equipment are intended to be used externally or invisibly. Okay. Like bedrooms, delivery room, ECG room, endoscopy room, neurology, radiology, therapy, MRI, etc. Okay. Now, what is Group 2 location? Medical location where applied parts are intended to be used in applications such as intercardiac procedures, operation theaters, and vital treatment, where discontinuity of supply can cause a danger to life. So difference between Group 1 and Group 2 is that in Group 2, if the power supply is disconnected, then it can endanger the life of the patient. Okay. That is known as Group 2. Otherwise, the areas where medical electrical equipment are used are Group 1 location. So examples of Group 2 location are operation theater, ICU, NICU, anesthetic room, operation preparation room, operation plaster room, and all the other critical rooms in the hospital. So details are mentioned in the IT standard annexure C, I think. Okay. So what are our protection goals? What are the things which we want to prevent, protect? Is protection against electric shock, protection against disconnection of power supply, and protection against fire. Okay. So protection against electric shock. I have tried to actually cover as many points as possible from the standard in this particular table, but definitely it is not full and complete. So we really need to go through in detail the standard to understand all the points. So there are various safety aspects which are common in designers for preventing the electric shock. Okay. First is prevention against direct and indirect contact. It can be done using SCLV, PLV. It is allowed in group 1 as well as group 2 location. Okay. Like using extra low voltage to prevent from electric shock is allowed in group 1 as well as group 2 location. Now, protection against direct contact. Okay. Placing of obstacles or placing out of reach is not permitted. Okay. And we should have a insulation on top of the live conductors or enclosures should be are required. Okay. Third is protection against indirect contact. So for this one, in group 1 location, disconnection of supply must be there to prevent against such voltages. Okay. And in group 2 locations, we must use the IT system. What is IT system? We will discuss in detail. And secondly, from overcurrent protection up to 32 ampere can be used, and residual current protection up to 30 milliampere. Okay. For group 2 location, use of IT system and protection coordination must be there. That also I will cover when I cover the IT system. Okay. Then third part is the supplementary equipotential bonding in group 1 as well as group 2 location with some extra provisions required for group 2 location. Okay. Second is the protection against disconnection of power supply. Okay. So first part is use of emergency power supply. So it must be there for group 1 as well as group 2 location. It can be a very large UPS or a diesel generator set available. Okay. For UPS, if means second part of safety provision is UPS. So for group 1 location, UPS is not required. You can rely on the generator. But in group 2 locations, one dedicated UPS per IT system or a single UPS supplying to multiple group 2 locations shall be used. Okay. So the a UPS backup along with the generator backup must be used in the group 2 location. Okay. Now coming to the changeover time. Changeover time less than 15 seconds must be there for all group 1 locations except for delivery room. So in this particular clause for changeover time, the delivery room is also included in group 2 location areas. It says that changeover time must be less than 0.5 seconds for all group 2 locations and delivery room. Okay. For group 1, it is 15 seconds. For group 2 location, it is 0.5 seconds, means 500 milliseconds. Okay. Now, special provisions are mentioned in part 8.3, which can be reviewed in detail. Now, coming to protection against fire, one special point mentioned here is that AFDDs are not allowed in group 1 and group 2 locations. In group 0 location, it may be used subject to risk assessment done prior. Okay. Second is the leakage current. RCDs shall be used with tripping at 30 milliampere for group 0 and group 1 locations. For group 2 locations, IT systems must be used. In detail, we are going to discuss. Overcurrent and short circuit protection should be there in group 1 and group 2, and in group 2 it should be with some special provision design. Okay. Now, coming to focusing on one thing which we have seen in the here are few electrical terms which may have observed, right? Like equipotential bonding, like UPS backup, generator backup, and RCD, overcurrent protection, right? AFDDs. These are all the terminologies which, as an electrical engineer, we know mostly. But there is one particular thing which is normally there is ignorance or there is very less application of this particular technology, and that is IT power supply system. It is not very common, and a lot of engineers around, they don't know about it. Okay, so that is why I'm going to cover that particular part in a little bit more detail. Okay, now I have just tried to show a typical grid connected power supply system, how it looks. TN, TNS system, TT system, whatever. I just simply want to show a grounded power supply system where transformer neutral is grounded. Okay. So here in this particular diagram, as you can see, there is a main source transformer. Okay. And this transformer neutral point is grounded. Okay. And then neutral is given to the load side, and earth conductor is also going from the neutral point to the load area. Okay, so suppose this is a distribution transformer near your complex. Okay, and this power is coming to your society. Okay, so L1 and neutral will go to, for example, A wing. L2 and neutral will go to B wing. L3 and neutral will go to C wing. Right. With all these three, consider you live in A wing. So here it is L1 and neutral. So L1 will come, it will get connected to the phase point of the socket, and neutral will come to the neutral point of the socket. And earth connection will be connected to the earthing point. Okay. Here, if you plug in a equipment, so that equipment will get connected here. So suppose this is the equipment. I have just made a very simple block diagram just to explain without any much of the complication. Okay. So this is the equipment. Now, if there is a fault in the equipment, the phase will try to touch the body. Okay. Through either directly or through some resistance. Okay. When this happens, the phase conductor will try, the current which is flowing in the phase will try to flow through the body back to the source. So what will happen here is that the current from the phase will come, it will go to the body. Now, as you can see here, the earth conductor is connected properly here. So it will go to the earth conductor. Follow my mouse pointer. I'll just take a pointer here. Pointer option. Okay, so it will go through from here, it will follow the earth conductor, and it will return to the transformer. Now, because the current has completed the path, fault path, that is why the leakage current will flow. Your residual current monitoring device or residual current detector, ELCB, or whatever you are using, earth fault protection, is going to detect that failure, that leakage current, and it is going to trip the circuit. Okay, so if it trips the circuit, okay, if it trips the circuit, there will be a blackout. Okay, blackouts are very unpleasant usually in any place, but if it is in hospital, it is really hazardous. Okay, you'll only be try to will try to figure out what is around, not able to detect what is what. Now, this is one scenario where your leakage current will cause a blackout. Now, suppose this earth conductor, which is there, which is flowing from the equipment to the body, is not, its integrity is not perfect and it is broken somewhere. So, in that scenario, what will happen? The current will not pass through the body. Okay, but rather it will try to find some other path. In that scenario, if a person, it touches the body, then the current will flow through the person's body, it will go to the ground, it will go back to the transformer. This will complete the loop. The person will get a severe shock. RCD may or may not trip depending on the amount of current flowing through the person's body. Okay, so from a smiling face to the electric shock affected person, it is really painful. If you must have witnessed someone who has got electric shock, you must be knowing it is not at all funny. Okay. Coming to the third point, that there is no person around. Okay, the phase conductor has touched the body. the current is trying to flow, but it is not having any clear path, but it is rather trying to leak through other utilities like some rebar, some leaking through the wall, or some other equipment body and all. Okay. So if the leakage current is flowing through this path is not intended to allow that leakage current to flow. So that is why what will happen is because of the current, there can be a heat, rise in temperature at the point where the current is moving. And if the temperature rises above certain degree, and if there is some fuel present around, it can cause a fire. Okay. So these are the three main aspects: electric shock, power failure, and fire, which are caused because of the. Okay, how to go in next slide. Okay. So these scenarios normally happen everywhere, but what will happen if it happens in the hospital operation theater? Okay. Patient or doctor may get an electric shock. Sometimes it will be fatal. Equipment may trip the source, causing loss of power to life support equipment. Such scenario may cause additional risk to the patient. Loss of power or tripping can be fatal for patient as well as the body functions are supported or substituted with the medical electrical equipment. Okay. Leakage current is sufficient enough may cause fire in presence of medical gases or other flammable materials. Now, what is the solution? We have discussed the problem. What is the solution? Solution is using the IT system. Now, what is the IT system? Just to explain in a very brief, what I've done is I've simply introduced one small isolation transformer before our socket outlet. Okay. And what I've done is here the neutral of the transformer was grounded. Here the neutral of the transformer is not grounded. It is a floating neutral system. Okay. In this scenario, what will happen when in the same situation when there is a fault, if a person touches the body, there is no way the current can return to the source. In this case, the source is the transformer. Okay, it has created isolation between the main circuit and this particular room. So that is why the transformer has become the source. There is no way the current can flow back to the source, and that is why the leakage current will not flow and this person will not get a shock, even in fault condition. If we replace this person with a wire directly from body to the ground, then also there will not be any leakage current. There is no risk of fire. So thus, in an ungrounded system, in case of an earth fault, there is no chance of leakage current. That is why nobody will get a shock. There will not be leakage or anything. Then system will continue to run without any problem. The only thing is that the resistance of this phase conductor with respect to ground will reduce because of the earth fault. Okay, and it needs to be detected in time so that we can take action. System is not tripping, right? So if the system is not tripping, there should be a way. Does this IMD approved by BIS? Okay, we can discuss that point at the end of the presentation. This particular, so there will not be any leakage current and it will display the resistance of the phase with respect to ground. And if the resistance is low, we say that there is a earth fault. So in this way, without tripping the system, only through monitoring the resistance, we are able to say that there is a earth fault. Okay, thus this makes a safer power supply system for operation theaters. Okay, now coming to the NEC SP30 2009. There are what I've observed in the standard, around 30% of the standard talks about the IT system. Okay, but just to say, just to make some point, that 6.1.3 recommends IT system with insulation monitoring device, remote alarm indication system, monitoring or overload high temperature of isolation transformer in all group 2 locations. And there are 7.4.3 and 7.1.1 also mentioned things in much detail. Okay. This is a typical architecture of which is this particular drawing is taken from the NEC this NEC standard only directly. So it shows a typical power supply system in a hospital. where there is a normal power supply and there is a emergency power supply, and there is a changeover switch which gives power to the UPS coming from the UPS. There is automatic changeover switch, and then we have an insulation monitoring device, isolation transformer. Okay, these are the all the components which are mentioned to be there. It should be there present in the typical power supply system in a operation system. Okay, so simplifying it more, a system after the isolation transformer will look like something like this. Okay, so there will be a isolation transformer. Okay, and then there will be a insulation monitoring device. The insulation monitoring device will take feedback, like input from the phase, okay, to measure the resistance. It will take the input from a current transformer in the outgoing of the isolation transformer to measure the current which it is feeding, and it will monitor the temperature of the transformer. If any of the parameters goes high, it will give an alarm. Okay, so just to be sure that the transformer itself does not fail, right? Then there is a fault location device which is able to, before discussing fault location, coming to the insulation monitoring device, this insulation monitoring device which measures the resistance of phase conductors, both phase conductors with respect to ground in real time. And it will display the values. If the resistance value goes below 50 kilo ohm, it will give an alarm. This is as per the NEC standard. Okay. Now we have a fault location system. When this insulation monitoring device gives an alarm that why there is a earth fault somewhere in your system, this fault location system will automatically detect which particular feeder is having a problem. Okay. All this information will be communicated to a remote monitoring panel through RS-485 network, and that remote monitoring panel will display the data of all operation theaters together at a place. If there is an alarm, it will show there is an alarm. Okay. Then additionally and optionally, we can have a SMS and call other alert system if there is a failure in the insulation fault or the isolation fault. Okay. Then we can have a surgeon control panel to monitor the complete monitor and control the complete equipment of the operation theaters together and from a single place. Okay. This is a typical isolation panel, which is around 1.7 meter height and 405 mm width and depth. Okay. So now isolation panel, this is how it looks like. It is recommended as per NEC SP30 2023, section 9 and IC 60364 7-710. Okay, for all group locations. Okay, so here is the detail. It says that it should not be further than 25 meters. It should not be placed. It should be there within the fire zone. Okay, and one medical isolation panel should be there for each operation theater. Such provisions and requirements are mentioned in the NEC standard. Okay, this is some photographs of isolation panel manufacturing from our factory. Okay. Coming to the isolation transformer, this is not a normal transformer which we see around. This is a special transformer which is having special requirements as per IEC 61558-2-15, and the NEC standard, Indian standard, clearly says that the transformer shall be in accordance with IEC 61558-2-15. So the NEC standard says the transformer should comply with the IEC standard. So that is why IC standard becomes applicable for the medical isolation transformer. They come in various sizes, right from 3.15 kVA to 10 kVA. Okay. The key requirements as per the IC standard are the leakage current from phase to phase, phase to ground, and phase to phase, phase to ground, primary, secondary must not be more than 0.5 milliampere. Okay. It should be a single phase transformer with power rating of 0.5 kVA to 10 kVA. Okay, and the voltage limit should be 250 volts. So this is the requirement of the medical isolation transformer as per NEC standard. We have a type test for this one for this standard for access. Okay, this is a medical isolation transformer manufacturing in our factory. As you can see, we do the complete assembly, winding, and everything. Okay, now coming to the insulation monitoring device, it is recommended as per IEC 61557-8 The same details are mentioned in the NEC standard also, and NEC standard also emphasizes that it should be compliant to IEC 6.557-8. The main requirement is that they should be able to detect if the insulation resistance value of the phase conductor with respect to ground, it goes below 50 kilo ohm. Okay. And there are some technical requirements like internal impedance should not be more than 10 kilo ohm, should not be visible. Measuring current 1 milliampere maximum. Okay, it should not cross that, and test voltage less than 25 volts. So are actually the device is complying much better than the standard. Okay. And this is a EDS 30 insulation fault location device. This is not mandatory as per the standard, but it is a good to have thing, because if there is a fault, the standard says that you must be able to locate the fault in a very short time. So you can do it manually, but if it is like it is always better that you get the location of the fault very soon. So that is why it is not a mandatory requirement, but it is good to have. Okay, so this is a insulation fault location device which looks in the panel. So it is the CTs are actually molded together, 6 CTs, and all the output of the circuit breakers are passing through the CTs in a core balance. As you can see, the phase 1, phase 2, both conductors are passing through the CT itself. So it is a core balance CT. Okay. Now the medical isolation panels with all these products and features, they come in various types. Okay. The first one will be the basic one, which is required as per NEC standard, is a device with isolation transformer and insulation monitoring device. Okay, which will detect only the insulation fault. Now the second one is insulation fault with insulation fault location system. Okay. Third is insulation fault with automatic changeover from main power to UPS power. And the more advanced one will be insulation fault with insulation fault location and automatic changeover system. Okay, so these are various varieties which are there. We can select as per the our design and budget. There are some additional products. This particular product is remote alarm indicator. It is recommended as per NEC SP30 2023. The requirement is that because a person cannot stay in front of the medical isolation panel continuously, so there should be a device which should be placed in a manned location where people can sit and continuously see that particular device and check if there is an alarm. Okay, that particular device, as per the standard mentioned, it is written that we should have a green signal lamp to indicate normal operation, yellow signal lamp which lights when the minimum value set for the insulation resistance is reached. Okay, means yellow light for alarm, green light for healthy, and an audible alarm which you can mute but cannot reset. Okay, when there is alarm, the alarm should be mute, but it should not be able to reset unless the fault is clear. So these are the requirements for this remote alarm panel which should be there. Now there is another one good to have product which is a alert through SMS and phone call. So we can have a IoT gateway installed inside the isolation panel, which can give a recall to the maintenance and operation person that there is a earth fault and you should take action. Now, why such a device is required? Because there was a time when people were sitting at a place in their office or in the manned location and were looking at all the alarms and everything. But nowadays, the engineers are moving continuously, and there are fair chances that at the time when the alarm came, nobody was there in the control room or in the nurse station to attend that alarm. In that scenario, such a phone call will be very helpful. It gives an extra protection layer for ensuring that no alarm is missed. Okay. Now there is an additional device, surgeon control panel, which can be installed inside the operation theater to control all the operation theater equipment from a single place. Okay. Now this is the end of all the topics and technical things which we are discussing. Now I am going to show a demonstration video which will give you a fair idea of what is the isolation panel and how it looks like from inside and how it works. Okay, so it will give a better understanding of what we have discussed so far. So the panel rating here is 10 kVA with insulation monitoring device, fault location, and automatic changeover switch. This is the type of panel which we are using here. This is a video which I recorded when I visited the factory. So this is isolation transformer. We have insulation monitoring device and changeover switch CPS30. Incoming fuse terminal block and earthing bus bar. Earthing bus bar is at the side, which you can see. Changeover contactor, incomer NCB, and a 24-volt transformer to power the insulation monitoring device. Okay. And here we can see the fault location device EPS30 and outgoing MCBs. Because it also does the distribution board function. Now, just to simulate an earth fault, I have connected one of the outgoing cables to the earthing circuit. Okay, just to simulate an earth fault so that we can create that earth fault and we can see that. So that particular feeder I have kept it off. So when I switch it on, that time the alarm should come. Okay, in this way I have simulated the earth fault. Now I'm switching on the power of the panel. The changeover switch and the insulation monitoring device have turned on. It is displaying a 750 kilo ohm resistance, which is very healthy and no current test current here. System is normal. Okay. Now I will switch on the faulty circuit. Then alarm should come. Okay. So I have switched on the faulty circuit. Now you can see less than 50 kilo ohm and the alarm is come. Right. Now, I just want to point out one point here. You know what I've done here? I have connected the phase conductor to the earth conductor directly with a plain wire, a single wire. There is a wire which I have connected a phase conductor to the earth. Now, just tell me, we are all electrical engineers. Just imagine what will happen if I do it at home. I take one wire and put it in the earth. There will be immediate short circuit or fire. The wire will burn within seconds, right? But here you can see we have comfortably done it without any problem. We are 200% sure there will not be any leakage, any current flowing there. Got the point? So this is also a demonstration of how the IT system prevents any type of leakage current at all from phase to ground in case of first order. It has shown alarm. Okay, one alarm is showing there. It is only showing an alarm. There is no tripping, no fire, no heating, no leakage current. And this ATS has detected that this particular feeder has caused the problem. Now the same data is displayed on a remote panel. You can see. As you can see, feeder number 6 of EDS1 is faulty. It is showing on the this one. Okay. And because this displays the indication of various IT systems, it is showing IT1, the first isolation panel, 6 feeder is having a problem. Okay. That is the end of the demonstration for medical isolation panel for hospital operation theatre as per IC 60364 7-710 and NEC SP30 2011. Okay. Now, just one more video, okay, just to visualize what will happen if there is a power failure during a cardiac procedure. Okay. So this is a person, his name is, just give him a name, maybe Prabhu Kumar. I don't know, he is looking foreigner, so he may not be Prabhu Kumar, some Wilson Churchill kind of person. Anyway, so he is very happy going to the operation theatre and getting his heart procedure done. Okay. So, 1 minute. This video contains like it is showing some visuals of the operation. Okay. So if you don't want to see that, actually it will show the organ. So if you don't want to see that, you can mute for or take away the eyes from your screen for some time. So we all know this is a video only for a demonstration, but the heart stopped, our heart stopped beating for a second when we saw suddenly what happened when the heart was in his hand and the light went off. You imagine what will happen to the doctors and the patient at that time when something so critical is going on and the light suddenly goes off, right? And we are the engineers. It's our responsibility to maintain the continuity of power supply in these situations. Okay. So final words, where such a system is required in operation theaters, ICUs, and other group 2 locations in hospitals. Why it is required? Because patient's life is at risk. It is whose responsibility? It is everybody's responsibility. Hospital owners, doctors, consultants, developers, contractors, technology providers, and vendors. Okay. So just I would like to end my talk with this particular quote from Quran. Whoever saves one innocent life, it is as if he has saved the whole mankind entirely. It is from Quran, Surah Maida, ayat number 32. Okay, so I am an engineer. I will do it through technology. Thank you very much.
Thank you, Mubarak Khan ji, for this wonderful presentation from your end. And I'm quite sure all the participants will learn a lot. And in fact, they must have learned a lot. And they will try to implement that thing whenever they come across the IT systems in their part. And I think now time to take some questions. I request the participant to raise hand so that I can invite you. I will unmute you to ask the question directly from Mubarak Khan ji, who has given a wonderful presentation of that IT system applicable for my hospitals, medical location as per NEC SP30 2020-23. Any question from any participant? Sir, you can stop sharing right now. Any question?
There are several questions in the chat also, and Mr. Kundu is raising hand.
Okay. Yes, there is one hand raised. Who is that? Kindly unmute, Gulab. There is one person want to say something.
I have unmute him. His name is Kunanduji.
Yes, please unmute. Mr. J also wants to say something. Kindly one by one. Kunanduji, please start your question.
So, luckily, I ended my presentation in time. It is almost 6. So, like,
Yes.
I was not
Very well
knowing
in
that I
time.
finished.
Very well in time.
Perfect.
Yes, Kunanduji. Gulab, allow him to unmute. Yes, please. Kindly switch on your camera. We want to see your face. Please start your question and switch on your camera.
Arora sir, can I speak? Kundu
Yes,
sir
yes.
is not able to communicate.
Yes, please.
Okay, thank you. Thank you for arranging such a wonderful session. Mubarak sir, thank you. I didn't join at right time, so I missed a lot of things. I hope Arora sir will put it on YouTube so I can see it from beginning. My question is regarding the fault what you created in the demo. You made a single fault. A line conductor was connected to earth. Suppose there is a double fault. Then what is the scenario with this IT panel?
Okay, so if I connect, it was phase connected to the earth. If I connect another phase to the earth in the same way, there will be fire without any question.
That only is it.
That is why we have insulation monitoring device and fault location system to detect the first earth fault and remove it as soon as possible. Under normal operating conditions, it is a little bit, there are very less probability that fault in phase 1 and phase 2 will come together. Okay? At a time with a very strong fault of direct short circuit. So that is why if there is a problem, there is an alarm, we should take an action directly and try to solve it rather than keeping it there, because system is not tripping. So some people may ignore it and leave it there and keep the operation on. But we should not do that. We should have an insulation monitoring and fault location system, detect the fault and eliminate it as soon as possible. Keep the system healthy.
There is one more follow-up question to this. Rajesh sir, can I speak? You want to speak
Yes. Please continue. You're welcome.
Actually, on the panel also, it was written that the panel supports 10 kVA for single phase. So, like, are these panel directly to be connected to single phase, or we need to have a 3-phase to single phase transformer in between that would provide that much of power? Because I have very limited knowledge in electrical distribution. So as I have heard, actually, I have not read somewhere that maximum we can do is like around 6 to 7 kilowatt per phase. So how, like, if anyone is drawing 10 kilowatt, is it good to do that way on single phase?
The first supply is that you can load as much as you want depending on the capacity of the transformer. The only thing is that all the 3 phases must be loaded equally. Okay. Second thing, from a 3-phase to use a single phase, what we need to do is we need to use phase and neutral. Okay. We don't need to convert 3-phase to single phase. We use phase and neutral. So suppose there is a building, there is a complex with A wing, B wing, C wing. So when the transformer is supplying power to this building, it will give one phase to A wing, one phase to B wing, one phase to C wing, and it will distribute the neutral to all the 3 buildings. What's the point? Now, if this power is coming to the operation theater, because I want to supply it through to a operation theater through IT system, that is why I am going to connect a single phase transformer whose primary is also single phase, secondary is also single phase, primary and secondary both are 230 volts. Both are 230 volts. It's the purpose of transformer is only to isolate the power supply from the input to the operation system. That is the only purpose. Okay.
Okay, thank you.
And
thank you
the
very
size
much.
of the transformer can be 3, 6, 10, whatever, depending on the requirement of the operation theater load. If the operation theater is consuming only at 8 kVA, so we can have 8 kVA. Okay. Yes, Ajay.
Sir, I would
Thank
like
you.
to elaborate on that. I will throw some light. The question was very valid. What happens when the second fault happens? But what happens in case of that IT system in hospital, especially in the ICU and operation theater? Usually only single phase system is used. And in single phase system, that first comes the isolation transformer. And that transformer is as per IC 61558-2-15, already explained very well. Then there is one insulation monitoring device that is as per IC 61557-8. Okay. In case there is some issues, because in that transformer, so many feeders are there. If there's some problem with any of the feeders, the insulation monitoring system give indication, give alarm. And the moment you get alarm, there are alarms in the shape of indication as well as in the shape of sound. And it is not going to reset unless until that is being attended by a person working in that hospital. That is the system of working. And your question was related to in case the second phase comes in contact with earth. Usually we are using the single phase transformer as I have seen the specification. And there is no second phase at all there. The chances are there. The only a particular feeder will come in contact with ground, and that will be through isolation transformer and will be monitored by insulation monitoring device, if I'm not wrong. Mubarak ji.
Sir, actually, when you use the isolation transformer, both the phases are 110 volts. Just hypothetically saying, 110 volts
right.
with respect to ground.
Yes. Basically, what happens that is the only purpose of isolation transformer. One side is delta, second side is star, and because of delta connection on one side and both are the same rating, there is no difference. If one side the primary is, let's say 10 volts, the secondary will be of the same voltage. There is no step down, step up transformer, that is the isolation transformer. The purpose is to keep that incomer separated from outgoing system, that is called the secondary system. That is the purpose of that isolation transformer in IT system.
Okay. We may go for the next question, please.
Okay, any question? Okay. Then I would like to invite the president of NFP Delhi chapter, Umesh Gupta ji, for vote of thanks.
Sir, there are some questions in the chat box.
Okay, we can take one by one.
Okay, so I'll take the questions. There is a question from, I'm not able to read because the laptop is too far. So the question is, sir, why there are separate earthing for all the diagnostic equipment? Even vendors insist none of goods. Okay, so what I understand from here, but the thing is that the different number of pits are not required. Mr. Rajesh Arora is a very good expert on this. We must
I have explained that thing many times through my videos as well as my talk many times. One location, one earthing system should be there. OLOE. That is the fundamental thing so far earthing system is concerned. OLOE. One location, one earthing should be the mantra.
Yes. Okay. So the second question, does this IMD was approved by BIS and the production according to CA? Please clarify. So BIS, CA normally don't talk about this in much detail. Rather, the NEC standard is there which has covered this particular topic in a detail. And it says that the installation monitoring device must be in according to IEC system 557-8.
Right.
So NEC also directly refers to the IEC standard, and the installation monitoring devices are all tested as per that standard.
Otherwise, the second document available is IS 17512 2020-21 requirement of electrical installation in medical location, that can be referred.
Okay. Now, one thing, what is the TAC Zenta module in the picture of NEC 2023? So I think you are referring to the picture which was there, which was having all the connections and all, the typical hospital architecture. I really don't know what is that TAC Zenta. So can't help you on this. That particular diagram is from actually Schneider's diagram. It is there. It is also there in the Schneider catalog. So you can go refer that. Okay. Now, what is the next question? Okay. So these are all the questions. Any more questions anybody is having, they can simply unmute and ask, or we can type a question in contact.
Otherwise, you can send your question to my email I have already given, and the answer will be given shortly. And now time to say goodbye, and before I say goodbye, there will be one talk through NFE President's Delhi chapter, Umesh Gupta ji. Vote of thanks will be given by him. And he will give his view and review on the webinar 29. Please kindly unmute and start, sir.
Thank you, Rajesh ji. I hope I am audible.
Yes, you are audible.
And I would also like to thank Mr. Khan for such a wonderful and very good presentation. And I hope the young engineers who are related to this field, especially with buildings like hospitals, they should be able to understand how important and critical is this topic. And I think it is very important also. Generally, it has been seen that the devices installed, such kind of systems installed to take care of the faulty conditions. But many times what happens that over a period of time, proper maintenance upkeep is not done. and whenever such conditions arise, the systems, whatever is required from such systems, these are not able to perform their duties just because of improper upkeep. So they will also understand what is the importance and importance of the maintenance.
Yeah, you are again muted. Unmute yourself.
Okay, I think I'm audible now. There
Yes.
was a call in between, sorry. So this way, the people, engineers especially, who are associated with this kind of buildings, hospitals, for them it is very important. They should understand and all related standards, codes, practices, and also how to upkeep and maintain the system, so that whenever these are required to perform such duties, these should not fail, and there should not be any unpleasant situations. We have heard during last 3 4 years many such incidences, especially in hospitals etc., where fire etc. has happened, and the lives of the people, patients, are compromised. So once again, I would like to thank Mr. Khan, Arora Saab, and his whole team, who is uh, giving us opportunity to learn such important topics, which will play a vital role in making the India electrically safe. Not only hospitals, but India. I think it is all from my side. Thank you once again.
Thank you. And with the last word from my side, thank you, Mubarak Khan ji, for giving wonderful presentation, insightful presentation, and definitely all the participants going to implement whatever they have learned from that important webinar that happened today at Igniting Power Engineers platform. With that, let's take a pledge. Let's make India free of electrical accidents because of fire or poor earthing. Let's make India safe. With that, thank you everyone. Thanks a lot. Thank you very much. We will be back with another webinar very soon.